Right. Last week we discussed the indices and some laws of indices, and we started the logarithm part. I think everybody read that notes and studied before today class. Right. So now we will today start the laws of logarithms. Laws of logarithms. Right. I'll anyhow again explain what is a logarithm and how to define a logarithm. Right. Now, when we consider this way, the number 100, you can write this 100 as a power of 10. It is 10 squared. 100 equals 10 squared. Right. Okay. Now this 100 we have expressed as a power of 10. No? Then this is called as index form of 100. Right. Now we convert this index form of 100 to logarithmic form. We write log log. That stands for logarithm. And this 100 we write here. This is the right hand side base, no? That base we bring as the base of this log here, 10. Now, the answer of this is the right hand side, this power. Okay. That is how we convert index form to logarithmic form. Understood? Right. Now, here this is read as how logarithm of 100 to the base 10. Logarithm of 100 to the base 10 is equal to 2. The meaning of this is, whenever you write this 100 as a power of 10, the required power of 10 is 2, as here. Okay. So when we consider this way, people, logarithm of n to the base x equals y. Suppose, how do you understand this? When we write this n as a power of x, the required power of x is this y. It means, in other words, this n we can write as x to the power y. So people, when we have this way, a logarithmic form of a number, that logarithmic form here, logarithmic form of n here we have. Now that has been converted to index form again, index form. Let's see how to convert this logarithmic form to this index form. What is the method? This number we take here, and this base of log this x we take to right, and we take its power this y. That we say usually x goes to right and keep this y on its head. Okay? X goes to right and x to the power y this way. Understood? Right. These things, of course, we learned last week. People, there we furthermore told, when we define the logarithm, we told this number should always be a positive value. That number should be a positive value. And this base also positive value, but another restriction is there. The base should not be equal to 1. The base of this logarithm should not be equal to 1. It should always be a positive value. That base should not be equal to 1. There are the restrictions we have to ensure when we define a logarithm. Okay. Now today, people, we supposed to discuss some important properties of logarithms. Sometimes in the class today, there are some newcomers. People, the previous class recording available in the group, the link available there. You have to watch that quickly, because these recordings very quickly I remove from the cloud. Okay, right. Now today, suppose people we discuss the laws of logarithms. Laws of logarithms. right? Okay. Now, in your oils, this laws of logarithms, you have used to work out questions, but you did not prove them. But as A-level students, A-level math students, you should know how to prove them. Understand? Okay? Yeah. People here, we supposed to discuss nearly 9 or 10, right? 9 or 10 laws. Okay. And the other thing is, right, people know the first law of logarithm. You have learned this in your oils, but you have not proved. But as A-level student, dear students, you should be able to prove this. Huh? Yeah. Yeah, the first one is this. Then write the next heading like this. Laws of logarithm. Laws of logarithms. Laws of logarithms. Right. Okay. The first law is this, people. We have two numbers, m and n. M and n. Of this m n product, we take log to the base a. See, left hand side we have product. This law says this product you can write as a sum of two log values of this m and n like this. See here, this is the rule. M n product left hand side we have log m n product to the base a. Now, when we have product like this, you can write that as a sum on the right hand side, taking this log of m and n separately, subject to the base simple a. This is the rule. Okay. People, then if we have a product like this, you can write as a sum, taking log of this first and second m and n numbers. Then see from the right hand side how to take the left. So on the right hand side, you can see sum of two log terms we have. The sum of two log terms we have. They have the same base. Log a here, log a here, same base. This log term plus this log term. When this way two log terms are available, that sum you can write this way, multiplying this m and n and writing log here. So therefore, people, in working out questions, right, sometimes we use from the left, we write the right hand side result. Some occasions we need from the right, the left result. That means when we have a sum like this, we should be able to write it like this. When we have product like this, sometimes we use that as a sum like this. Understood, people? The both directions we use. Now, let's see how to prove this. Every people, these laws, we should be able to prove as a student. In oil, of course, without proof, you use them to work out questions, right? But as a students, you should be able to prove them, right? Let's see how to prove these people, right? Write the proof. Write the proof, right? Now, this is how I prove this. Now, you know, when we take people this term, right? When you take this term, right? This term has finally an answer, no? I am going to take this logarithm of m to the base a, its answer is x, right? Why? For instance, people suppose that is a logarithm 1000 to the base 10. You know this answer. This answer is 3, no? How do you think here? When we write this 1000 as a power of 10, the required power of 10 is this 3. Therefore, the answer of this is 3. Likewise, people, for this log m to the base a, this should have certain answer. That is, I am going to assume as 6. Also, this one, I am going to assume as y. This way we take them. Understood? Right. Now, this way, this is the logarithmic form of m. We know how to convert this logarithmic form to index form. Logarithmic form you can convert to index form. How, people? Remove this log, write this m here, bring this a to right hand, keep this x on its head, a to power x. And here n is equal to e to the power y. Remove log, keep n left hand side, bring this a to right hand, put that y on the head of a. That's how we do this. Now people, what I do next is, I multiply this m and n. This m and this n I multiply. When you multiply m and n, substitute for m, what is that? E to the power x multiplied by n e to the power y. This way, I substitute for m in, for m e to the power x, for n e to the power y. Now, when we multiply like this, you know, this base and this base are equal, people. Then by using the first index law we learned, when the bases are equal and when they are multiplied, you know the powers we can add. Now we can apply this law here. Then what do you get? The I mean e to the power x plus y coming. Correct, no? Adding this and this. That is by using the first index law we learned last week. Okay. Now people here think this m in. M is a number, no? M is a number. N also number. Suppose m is 2 and n is 5. Then this m in product means 2 multiplied by 5, no? What is that? It is 10. Then really people, the left hand side we have a certain single number. 10. 10. 10 has been expressed as a power of a. That means we have index form of this left hand side number. And you know, when we have index form of a number, how to convert that to logarithmic form. Understood? How to convert that to logarithmic form, people? Yes? How to convert that to logarithmic form? We write m in here in the left hand side, and we write log here, right? The right hand side base, this we bring as the base of this log here. That is how we convert index form to logarithmic form. Then this is equal to what, people? This is equal to the right hand side, this power, x plus y. We got up to here. I think you can understand that well. Now what we do, we substitute for this x and y. X and y. What is your x? X is log m to the base a. Your y, log n to the base a. Then when you put this x here, log m to the base a plus log n to the base a. It left hand side we have like this, people here. Okay. Then this completes the proof, right? This is how we prove that result. Understood? Right? Then start the proof, dear students. Right. I think you finished. Right? In your IELTS, you didn't prove this, I think. Without proving, you use this directly to get the answers. But as IELTS students, I should be able to prove this, Okay. And in your first, second term tests. Usually, one of these proof we supposed to do in this lesson definitely coming, right? But in AL examination, people in the papers, among the papers, I didn't see any question under this logarithm to prove, but this lesson is very useful to work out some questions in other lessons. These theories are very important and useful, right? Okay. Now we'll take a note like this. Right. We'll take down a note. Now suppose, dear students, we have something like this. Logarithm to the base a. Suppose in this bracket, we have product of four numbers like this, PQRS. Product of four numbers, PQRS we have, right? Now by extending the same rule, we can obtain, right, a certain answer for this, right? Yeah, now I'm going to write the same thing like this. Log base a. Okay. People, you know, when we multiply four real numbers like this, 2 into 3 into 5 into 8, these four numbers. When you multiply, first you can multiply 2 and 3 like this, and that we multiply by the product of 5 and 8. This way we can write, no? So using that, I can write this PQRS, the product of these four numbers. I can write first PQ together and RS separated together like this. In between this, inside two brackets, there is a multiplication sign as we have there. I think you can understand that. Now, you know, people, when we multiply this 2 and 3, we get single number, no? It is 6. Here also 5 and 8, single number, it is 40. Like that, when you multiply this P and Q together, we should get single number as its answer. I am going to just suppose that answer as people capital M. Here answer as capital M. Then you can see this within bracket we have M in product. It's like this now. M in product, when we have that, you can write like this. Understood? Then I can write this one this way. Log A PQ here plus log A RS here. I think you can understand that clearly. Now, what we do here, people, now we think this P and Q are two separate numbers as here. Then its first number, this M, this P, I am going to assume as M. The second number Q, I am going to assume as N. Right? This way. Then again, when you consider this one, this has what? Log M in product to the base A. Again, now this takes the form this. Then this right hand side we can apply for this. Then what do you get there? Log P to the base A plus log Q to the base A we get. Similarly, I take here also this R as M and this S as N. There also we have M in product. Then for that also we can apply this. Then we can write it like this. See here, log A P plus log A Q plus log A R plus log A S. This way we can write. Then what do we have the left hand side? Left hand side we have is people log to the base A P Q R S product. See here, not only for two numbers product, but if there are four numbers in the product, still this can be extended. How? Taking log of each of this number here to the base A, we add them. Understand? So suppose here we have 6 numbers in the product. Then we can write the right hand side. How? Taking log of each 6 numbers, subject to the base A, and we add them on right hand side. This way we can extend the result. People converse result. But converse result means, look at this. On the right hand side, we have sum of 4 log terms, with the same base A. Here, sum between any 2 log terms, we have addition sign. Sum of 4 log terms with the base A here. Right, same base. Then that sum you can write as in the left hand side. How? Multiplying this, and writing that subject to the base A. Understood? So therefore, you should understand the rightward use of the formula and the leftward use of the formula. In the sense, from the left hand side, how to write the right, and from the right hand side, how to write the left. Right? So then people will take down this as a knot. This line also we have log base A, P, Q, R, S. Right now, you finish? Right. Right now, shall we go to the second one, second law? Right now, people, as homework, you must prove this again. You must prove this until you're familiar. You must prove this. Only thing is, right? People, now you know, when we do maths, of course, we never say we read maths, no. We say we studied maths. Really, studying maths means you must work out questions, right? You know, by hearing, you can't learn maths. By seeing, by watching something, you can't learn maths. To learn maths, people, we have to work out. We have to do questions. Only doing, you can improve this. So therefore, these things you must again do yourself. Take a paper, piece of paper, and first by looking at this, do this. Secondly, close that book, and by memorizing the things, you must do this. Okay? Until you familiar this, you have to do them. People, at the very beginning, if you practice like this, your brain will be forming to this way the things in the future. So that nature of the brain we need in the future to do maths in AL, right? AL mean people, AL maths means most of the time, really, we do everything using our practice, having a good memory with logic, right? So maths questions nobody can do by hearting them. Maths question nobody can do by hearting, right? By hearting means you know, right? So you know when we learn in biology or any other subjects, when you consider now biology or science, right? So when you consider a cross section of human heart, forever the same, no? So therefore, you can really Remember that, because nothing will change in the heart. Forever the same. Cross-section is the same. Right? Now, there you can remember. Then you can by heart. Below this valve, this is available. On the right of that, this is available. Left of this is available. On this way, we have a muscle, and so on. You can by heart that. Never mind, because if you can remember that one, then you can answer any part in the exam or wherever asking about the heart. But people in mathematics, you can't by heart like that. One question is different from another question. That occasion, you must have these formulae. They are called as tools. You should have a good idea about the tools. Now, people, the weapon. Now, suppose in a war, you are given some different types of weapons. If you don't know how to operate that, when to operate that, where to operate that, people, no point of having that weapons with you. Understand? So by hearting, okay, first I use this weapon and then attack to the enemy, and so on. Once you by heart, people, you can't do that one in a war. Like that, you should have this formula will in your mind. Okay. And you have practice using this formula to work out questions. Then only we realize how to use, when to use this formula. Like that, all the formula people, we have to first learn like this, and we must do questions, involved in them, right? Then only you get the idea how to use this formula, when to use this formula, where to use this formula. Then once we do like that, some questions, people, now you are okay. Right? Now, in this situation, now you are getting the question. Now you know, by looking at that question, to get this part, this formula I have to use. To get this answer, this formula I have to use. Then only, people, finally, you can work out the question. Okay? Then you know all the weapons you have. This time the enemy coming to us in this way, then this is the weapon I must use to attack them. So therefore, people, you should have a good knowledge regarding first one, the formula, how to prove that and what is the formula. Secondly, using the formula, we have to do some questions. Okay, then only, people, all that required environment forming in your mind. If you practice like this to do maths, people, I think the maths is the very easiest subject in the world. Understand? Very easiest subject. So therefore, people, at once don't think that at the very first question itself, right, you can learn everything in maths. Understand? At the very first question, suppose you get the answer, then don't think that you can. No. You must do more sums, people. Proportional to number of questions you do, the knowledge accumulate into your mind, your skill improving, your confidence improving, people, then more chance of getting the answer for the next question. So therefore, don't be hurried at the beginning to learn about maths. Gradually do, people. Now, you know, when we just talk about now, for instance, if we consider, people, other subjects like economics, like biology, like chemistry. See, people, in chemistry, I think most of you are learning chemistry now. In chemistry, people, the atomic structure is the first lesson. In that atomic structure, people, the ancient, the way practicals done by the scientists, the things they discovered. So then finally, the reason why it is rejected, and so on, many things like a story, you will learn. People, hearing this is very interesting. Then once you get the note there regarding these things, people, that's all right. That is enough for your knowledge. There are, of course, nothing testing other than that. Even at the examination, a question is asking, one or two questions asking, who discovered this? In the MCQ only asking, given 5 questions, 5 answers. When? And so on, such questions asking. Just having a good memory, you can answer those. And biology, when we consider, people, lots of things to explain, and very interesting. We can hear, we can see, very interesting, right? We can, of course, elapse time. That means we can consume time by learning them. No tired to mind. No tired to mind. Very interesting. But people, maths is not like that. Now here we learn the formula. In proving the formula also, we use our method. That method, of course, in our day-to-day life, we can't see. We never use. In a separate world, we go for this one to prove. And we got another one like this. After proving people, now we have to test what is the use of this. How to use this one. To test that people, we have to work out a question. When you work out a question, some students, they can't get the answer. Some students, they get the answer. Those who can't get the answer, really, they have no enough practice of doing question number 1. Some students, they have not understood how to use this formula. Then those who got the answer, they think that we are okay in maths, we can do. Others, they suddenly take a decision, maths is difficult, I can't do maths. Suddenly they change the stream. They first change that to biology. My experience, I'm talking people. So that's why I told you people, at the beginning by 2-3 questions, 2-3 classes, right? 2-3 months going to the classes. Don't think that you can improve maths at once. It takes little time, people. That depends on you. Okay, your capability of understanding maths, right? The skills of students, different people. Some people they start to catch something at once. Some people they take more time. But people, anyhow, depending on the student's nature, there's a certain time to catch, to come to the track. Until you are coming to that track, people, don't be hurried. Don't be hurried, right? So therefore, this maths is, this at the moment you are given something, at the moment your knowledge is testing. Your knowledge is tested at the same moment. Knowledge means what? Using this thing, how to do this, right? Theory, question, answer asking, right? Same time, this all 3 happens. Not like the early subjects. Chemistry, by reading as homework and thinking a little bit about that history, leisurely you can answer next day. But people, when we do maths, we do the formula, then we do a question. If we can't accept the formula, how to work out the question using it, if you don't get that idea at that moment, you feel that maths is difficult or you can't do maths. Don't take decisions like this. It takes certain time, people. Don't be hurried, right? According to my experience, most of the students, they come to maths class at the beginning, and first, second, third classes, they change to what? Other subjects. First step is biology, starting from maths, then go to biology. Biology also, people, some students, they stay in the class like more than maths, however. More than maths class. Suppose in the maths class, they stay 3 weeks. Biology class, like 3 months they stay. There are also some students, they go to what? Commerce after that. Okay, commerce after that. Like that, the students change the streams. But people remember, everybody can do maths. Everybody can do maths. But people, at the very beginning, your dedication to learn the things available in maths, right? Very important. You have to dedicate, right? You have to dedicate. Until you get that thing, if you can patiently stay in the class, I think everybody can do maths. Everybody can do maths, right? So therefore, at the beginning, people, don't be hurried. Don't be hurried, right? Okay, another thing is, people, if somebody can do maths and go to examination, suppose getting simple pass for maths, people, this is very valuable throughout the life. Very valuable throughout the life, right? So now this subject is a very logical subject, right? If somebody has 3 simplest passes, doing maths people. There are more job opportunities for those guys in our job market. And more avenues they have to go their higher studies. And meantime, people, suppose we don't do that both I explained now, they have at least a good what? Brain thinking logically and taking good decisions timely. At least that also you have. That is worthwhile throughout the life. So therefore, people, most important things you can bring to you people, it is not easy. You have to dedicate. You have to dedicate. Then only people we can get most important things to our life. Right? So without dedicating, sacrificing, if we get something to your life easily, people, I am not sure whether it is a valuable thing. Inside that, when you analyze that, it is something having a certain error in it. Therefore, people, I say this one, if somebody really willing to do maths, right, while we are doing like this, if you find some difficulties, people don't take sudden decisions, no, I don't do maths, right? Patiently do this, people. Every day do these things until you familiar these things. I am sure very near future, there's a turning point. You get the idea, no, I can do. Little by little, you can see a certain improve in your skills. People, until then, people patiently study that. Okay? Hey, everybody can do, people. Maths is really another language. Understand? Another language. That language we can understand, right? If you are okay with the alphabet first, no? Right? Then, until you're familiar with that, you have to be patient. Patient, you have to learn this. Right. Okay. Now, this is the first law, people. Right. These things you must do again as homework. Right. So now, best thing is to do, best thing is getting these things to your mind, these people. Think now you are a teacher. Under you, some students now learning. Now think, you are not teacher. Just think. Just think. Now you are a teacher in a school or in a tuition class. Right. Some students coming under you now, learning under you. Now you are going to teach this one. Right. Take a piece of paper, thinking as I am a teacher. Now explain to the students. Take like this, and then we get down like. When you practice like that, very easily and very good confidence, you can remember everything. Forever, that memory available in your mind. So that's not the easiest way of people keeping something in your memory a long period of time and getting something to your mind, right, by understanding 100%. So once you teach like that, people, you get a certain extra responsible. I am the teacher. If I go wrong, of course, that is not good for you. So then when you learn something, you would think twice, sometimes more than twice. Then people automatically, you can absorb thoroughly this to your mind. Understand? So that is another way to get something to your mind easily. Understood, people? Right. Okay. Now we go to the second law. Second law, right? Go to second law. Number 2. Second law, number 2. Right. Logarithm base A. Here we have a division. M divided by N. I think you can remember this formula. When we have this way, a division, in your IELTS you have learned this division you can write as a difference of two log terms. We write log term here, the same base in the left hand side we must write, and minus log term the same base. This first number of the log is this numerator. Second number of the log is this denominator, like this. This way you can write the second law. Okay, second law. Right. Write down the second law, number 2. Yeah. We'll see, people, how to prove this. Let's see how to prove this. Another easy proof we have there. Right. Now, people, we will do together the proof. Right? Yeah, I'll help you. Right? Using my instructions, do your next step. And so on, we'll move to the last answer. Okay? I can't see anybody here, but I think that you actually obey my advices and do the questions according to my instructions. Then we can prove this very easily, and thereby you can improve your skills also very easily. Right. People, now I take this one as x. I take that log m to the base a as x, and this as y. This way y. Next line, people, convert this logarithmic form to index form and this logarithmic form to index form. That's the next line. Write down that, converting them to index form. Then what do you get? Here m equals a to the power x. Here n equals a to the power y. That also you can understand, no? Right. People, the next line is, I divide this m by n. I divide this m by n. This m we divide by n. Substitute for m, a to the power x. Substitute for n, a to the power y. Correct, no? I think up to here, you could understand well. Right. Now, once you look at this, you must get certain idea. What is that idea? To apply here the index law. We learned, people, last week index laws. When this way, having the same basis, when the numbers are divided, we can simplify this, subtracting this denominator power from the numerator power subject to the same base a. Second index law we learned. Then I can write this left hand side m upon n. Now, people, applying that index law, a x minus y. This way we can write it. Okay. Now, when you consider very carefully the left hand side, people, m divided by n divided by n will give us finally one number. For instance, if we take m as 10, n as 5, 10 by 5 is 2. This m by n is finally a single number. That single number has been expressed as a what, people? Power. That means of that single number, index form only available. Now you know how to convert this index form to logarithmic form. Now convert that to logarithmic form. How? Log this number m upon n, and we'll write that as within a bracket like this, right? Though you don't write that one, never mind, correct? Now we'll bring this a as the base of log. Now its answer going to be, people, the right hand side is power x minus y. Converting that index form to logarithmic form. Now we have finished proving this. Only thing now we have to substitute for x and y. Okay. So then I can substitute for x. Logarithm to the base a m upon n. Your x log m minus your y log n. This way we can prove that, right? Very easy proof. Very easy proof. Right now, here also people, you should know how to use this. Yeah, here when we have this way fraction division, that you can write as a difference of two log terms. What are the converse? When we have this way difference of two log terms, you can write it as a fraction like this. There, see the base of log the same. Right, then you have to remember, if you have a ratio or fraction, fraction and ratio be the same people. Huh? If you have a fraction like this, the fraction we can write as a difference of log. If you have a difference, you can write that as a fraction. Okay, right. Now let's see, take in one example like this. Right. We'll take another note here, people. Right. Note. Now I'm going to write something like this. Log A P minus log A Q here plus log A R minus log A S. This way we have logarithmic expression. Okay. Now asking us to simplify this. People, simplifying mean we supposed to obtain for that a simple expression. This huge expression we need to reduce to simple expression. That is the meaning of simplifying. Okay. People, let's see how to do this. You can see there are 4 log terms here. Out of that 4 log terms, this log term and this log term are positive. Why? People, when we consider any term, its own sign. Sign means plus or minus, no, basically. Its own sign is always before the term. Here, this term, its sign is before this. Before this, we don't have any sign, means it is positive sign. When you consider this log term, its sign is minus. When you consider this log term, its sign is minus. When you consider this log term, its sign is plus. Understood? Now, I am going to write this on the right hand side of the equal sign only I am supposed to write now, but I write that here. Right? The first positive log terms, dear students, we write together like this. This term and this term. Right. After that, we write this negative log terms. Minus log A Q minus log A is like this, we write. Okay. People, I didn't change anything there. I wrote the positive log terms together and negative log terms separately together. That is to say, when we have people this way a certain simplification, this simplification, this expression you can write in 2 and 4 first like this, minus 3 and minus 6, second like this. The same thing I did here. Right. Now, the next line I am going to do, people, here these 2 log terms, this log term has minus sign, this log term also has minus sign. Okay. That minus sign I take out from a bracket. You know, when we have minus x minus y in your oils, under the factor lesson, you have learned, people, this way when you take this minus sign out means we take minus 1 out. Minus 1 means minus sign. When you take this way minus sign out from a bracket, right, the both terms, this and this, will get opposite sign inside the bracket as this way, x plus y. Correct, no? Like that, people, by this log term and this log term, take this minus sign out. Then what do you get there? Minus, open bracket now. Both then should be within bracket, positive like this. This way. And here we have log AP plus log AR. This way we get. I think up to here you can understand clearly. Now, see here, if I write these two terms within a bracket like this, now see the earlier, remember the earlier formula? This way, when we have sum of two log terms, we can write this sum of two log terms. How? Multiplying these two numbers and write in log. The same thing within bracket here we have, people. Then how to write this? Again, multiplying this q and s and write in log. Understood? Now you can write that. Understood? Right. Are we come to that, people? Now I'm going to erase this part. To write that here. Yeah, then I can write it log base A, this product, no? P and R, PR, minus log QS, base A, QS, this way. Right. Now what we have? Now what we have? Now we have here difference of two log terms. Then this expression is like this. Difference of two log terms. When we have this way, difference of two log terms, you know, people, that difference we can write as a division like this. There the numerator number going to be the number with the positive log term. Second, denominator number going to be the number of the log term. The log term has minus sign. If you apply that way here, people, log base A, within bracket we can now write positive log term is this, PR should come to numerator. This QS should come to denominator like this. Right? Now we wrote this thing for this long left hand side. Then I can write the result. Therefore, we can write what? This left hand side, log AP minus log AQ plus log AR minus log AS equal to this. Log A PR divided by QS. This way. Then this long expression, people, we got very small answer like this. Then it is called as a simplifying. Simplifying. Simplifying means we take a small something instead of a bigger one. Now this is how we take that answer. People, now in getting this result, we had to use how many steps? Right? 1, 2, 3 steps we had to use. By the first step only we got this answer. Shall we think to take this answer without showing the steps? Without showing the steps, shall we see a certain method to get this answer quickly? Because this kind of simplification in AL people, you won't get marks. So very simple simplifications. But in OL people, you get marks for these steps. But now you are doing advanced level, no? Advanced level for the steps, these, of course, you won't get marks because these logarithms we use in a certain question, under a certain part, in that part also at a certain place to get a small answer only, this log we use in AL. So those steps of all, then you won't get marks. So therefore, no point of using these steps to get this answer. So therefore, that occasion, most important thing is to get this simplified answer of this quickly. Now let's see, people, what is that? Yeah. Now here, right hand side. See here, what are these P and R? P and R are the numbers in the positive log terms here. Positive log terms, these numbers we multiply and write above the line. What are these QNs? Negative log terms, the numbers, Q and R. Those numbers we multiply and write below the line. And write in that way fraction right before log. Understand? In one step, you can take the answer. Then people, shall we do this one by using that? Another example. Will write. What is that? This is suppose minus log A alpha minus log A beta plus log A gamma plus log A delta minus log A lambda. You take another one more. I'll take another people. Log A 5 like this. These all are Greek letters. So I think you will receive the tutorial. With the tutorial, you will get a small booklet. In that, people, all Greek alphabets that we use in our ALs mentioned there. You can go through that and familiar with this, but alphabets in Greek alphabet, right? So thereby you can formulate very easily like this. We will now suppose we have this way, a certain long logarithmic expression. Now see how to take its most simplified form by using that experience. Take the answer for these people, the simplified answer. You know the method now. You know the method. Now, we can write it like this, people, very easily. Log base C. Okay. We write bracket. Right. Within bracket, now numerator, denominator. People, we told for the numerator what values we get. Of the positive log terms, the numbers only come into numerator as a product. So then what are the positive log terms? This is positive, this is positive, this is positive. Gamma, delta, 5. Product, gamma, delta, 5. Negative log terms, people. This term, this term, this term. What do you get? Alpha, beta, lambda. Alpha, beta, lambda. Now, this is how we take that answer. Correct, no? Okay, right. Now, people, so far we did 2, right? Another, we have really altogether 10. Out of that 10, really 2 of them are very easy. The rest ones are very important. Yeah, now we'll come to the third one. We come to the third one. Third one is this. Third one is this, people. Suppose here we have log base A. We have a number here m, but this time this m has a power r. M has a power r here. Okay, there's a power r here. This number m has a power r. Understood? Then this law says this power r of this m we can bring before. This also you have done in your oils. You can take this power r of this m before this log term, and you can write it how? R log am. This way you can write it. R log am. So therefore, this law also you should understand, people, to use in the both directions. Both directions in the sense, now from left to right, how to use this? In the left, this r is at the power of m. Left to right use means, people, this r you can bring before and you can write it like this. Right to left use is what, people? Now it is this, the log term has coefficient r. This number is called as a coefficient. You know, when we write 2x, people, this 2 is called as the coefficient. When you write x cube, before that we have 2/3. 2/3 x cube. This 2/3 is called as the coefficient of x cube. Like that, this log term has the coefficient r. That coefficient you can put as the power of m. That's the reverse use. Okay. If it is at the power, you can bring that before. If it is before, you can put that as the power of m. Understood? Both directions, you should understand how to use. Then we'll see how to prove this. Come to proof, people. Proof. Proof, right? Right. This time the proof is done like this. I'm going to take this log term as x. We take log m to the base a. I'm going to take its answer as x, its value as x. Right? Now, we convert this to index form. When you convert this to index form, what do you get there? This m is equal to e to the power x. Okay, no? Right. Right. Now, you know, people, if we have x is 2, x is 2. If x is 2, how to find x squared? X squared, you know, 2 squared. It says, when we have this way, 2 numbers equal, then in the left and right, any power again become equal. X is equal to 2, then x cube is equal to 2 cube. x4 is equal to 2 to the power 4. Like that, when this way 2 numbers are equal, the same power in the left and right again equal. Like that here, people, a to the power x finally give us what? Certain single answer. Suppose a is 2, x is 3, then this is nothing but 2 to the power 3 gives us 8. Therefore, this is a single number, even though this appears as a power. Then really we have this number and the right hand side number equal. When this way 2 numbers are equal, people, any power in the left and right again become equal. So therefore, I take in the left and right power simple r. I take the left and right power simple r. Then we write it like this. Raising both sides to the power r. To the power simple r. Then what do we get? Left hand side m to the power r equals right hand side a to the power x to the power r, like this we get. Right. Now people, you know, here on the right hand side, inside the bracket we have power, outside the bracket we have a power. right? Under index law, we learn people how to simplify this situation. We said what the inner power and this outer power we have to multiply to simplify this. Then we can apply that next. Then what we get there? Then what do you get there, people? M to the power r is equal to, people, a to the power xr. Multiplying that inner power x and outer power r. Okay. Now you can see here this right hand side is a certain number. Left hand side also a certain number. People, now you can think it like this. M to the power r finally give us this way a single answer to left hand side. Suppose m is 5, r is 2, we get 5 squared, 25. Single answer finally comes. Then this single number now is equal to power of a. This means, people, in the left hand side of this single number m to the power r, its index form only here we have. Now this index form of this m to the power r, we can convert to logarithmic form. How? Write in log and m to the power r here. Write in the right hand side base as the base of log like this. Now it is equal to the right hand side power xr. Like this we can write it. xr. Now the right hand side xr, we can write as rx like this. Because you know, when you multiply 2 and 3, though you interchange this order 3 into 2, still the answers mean the same using that. Now see what happens there. For this x, now you can substitute. What is x? X equals this, right? Then you get what? Log m to the power r to the base a equals r into this x log a. This is how we prove that result. This is how we prove that result. Okay, right. Prove the result, people. Okay, people, right? No, right. Right. Now let's see. Using all these 3 laws so far, we learned how to implement them in a certain question, right? Now we'll come to a simplification question using these 3 laws we so far we learned. Yeah. Now suppose people, we are given a certain question asking to simplify. Simplify. This way we are given. First one is this 2 log a x, right? Minus 1/3 log a y plus log a z minus 3 log a t. Right. You are given something like this. Ask you to simplify. Right, people? Now let's see how to use these 3 laws so far we learned to simplify this. Okay, first write down the question. Yeah. Now let's see how to take this. Yeah. Now the converse of this law only this time we use. Converse means what, people? From the right hand side we write left. Right hand side before this log term we have a coefficient that you can bring as the power of m this way to write. Understood? Now if I use that, people, this 2 we can bring as the power of x here. This 1/3 we can bring as the power of y here. This 3 we can bring as power of t here. Understood? Then we can write the next line by reverse use of that third law we learned. Okay. After that, people, first, what do you get there? Log a x squared minus log a y to the power 1/3 plus log a z minus log a, this 3 we put here t cube, right? Correct, no? The third law we learned, now we used. Now we'll apply the early 2 laws together. In this expression, you know, there are plus log terms as well as negative log terms. We learned earlier, people, when we have an expression containing positive and negative log terms, both types, we know how to write that expression quickly. How, people? We write log, base A we write, open the bracket, numerator and denominator we form like this. Numerator we write, people, the values of positive log terms. What are the positive log terms? This is positive, this is positive. X squared is z. Right. X squared and z we have to write as a product. Denominator we write product of the negative log terms, y to the power 1/3 and t cube. This is how we simplify this. Understood? Yeah. Okay. These 3 log terms, dear students, these 3 laws of the log, you used in your OLs. The rest ones we supposed to discuss here, you have not learned in your OLs. They are new for you, right? Okay. Let's see in our number 4, fourth law. Right. Number 4. fourth law. Right. It is this. Suppose we write this way, people, logarithm of 100 to the base 10. You know the answer of this. It is 2, no? Yeah. Because when we write this way, this log term, it has the denominator, it is 1. Now, for instance, people, when we write 100, this is really 100 divided by 1. Okay. Any real number is a fraction. When we write 1000, 1000 means 1000 divided by 1. Understood? Like that, when we write this log 100 to the base 10, really, it is at the numerator. The denominator is 1. Understood? This law states, people, we can write, taking this numerator log terms, bringing that to denominator. Then what happens is, the base and this number interchange the places. This numerator log term you can bring to denominator, and that log term you can write the denominator. There, what happens is, these two numbers exchange the places. That's what this says. When you bring this log term to denominator, people, the numerator now remains 1. When I write that log term at the denominator, these two numbers exchange the places. This way we can write. This is the third law. This is the third law. Okay. Then we'll write the third law. Right, we write the third law. Number 3. It is log b to the base a equals 1 upon log a to the base b. This is the third law. Now here also we need to prove this. We need to prove this. See how to prove this. Come to prove. Right. People, the right hand side, this log a to the base b, I take as x. Let logarithm of a to the base b, I take as x. Correct, no? For this one, there's a certain answer, no? I take that as x. Now, this logarithmic form I can convert to index form now. How? A equals b to the power x, like this. A equals b to the power x. Okay? Right. Now, suppose like this, dear students, you are given x squared equals 4. How do you find this x? To find x in your small grades, you have learned if x squared equals 4, to find x, you have to take the square root of 4. That occasion, you have to put plus or minus. Right. People, in this case, square root means power half. The square root of 4 means this is really 4 to the power half. The square root means the power half. Right. I'll explain the way of coming to this 4, the power half. Right? It is coming like this. X squared equals 4. People, we need to find this x, no? Finding x means we need to find x to the power 1. We are really going to find this x to the power 1. That means in this equation, this power of x presently 2, the place of 2 should be 1. For this, what we do, the left-hand side and right-hand side, the left-hand side and right-hand side, the numbers are equal. No? In the left and right, we take the same power half. Earlier I told you, when two numbers are equal, of the numbers, any power again equal. If two numbers are equal, any power of them are equal. Using that, this is equal to this. Then the left and right, we take the power half. Then x squared power half, 4 power half. This is what we get. You know how to simplify left hand side. We have inner power 2, we have outer power 2. We should multiply this inner power with the outer power to simplify the left hand side. 2 multiplied by half. People, when you multiply 2 by half, what do you get? Half into 2 means 1, no? Then here, when you multiply this 2 and half, we get x to the power 1 equals, now see here, power half came. We told you power half means what? Square root. This is how people we get. You know, x to the power 1 means x. Really, this is what happens there. Understood? Now, using that, here also, on both sides of these people, I am going to take power 1 upon x. On both sides, I am going to take power 1 upon x. Understood? Both sides, I am going to take power 1 upon x. And now, I write taking power 1 over x on both sides. On both sides. What do you get? A to the power 1 over x in the left hand side, right hand side, b to the power x, whole thing to the power 1 upon x. This way we get. Now we are supposed to simplify this. We are supposed to simplify this. How? Here, inner power x should be multiplied with this outer power 1 upon x. X and 1 upon x, when you multiply, see what happens. X multiplied by 1 upon x. Below this x, we have 1. No? This 6 and this 6, you can cancel. We get 1 each. 1 into 1 is 1 people. 1 into 1 is 1. 1 upon 1, this is nothing but 1. That means, when you multiply this inner power with the outer power, we get the power of b 1. B, a to the power 1 upon x is equal to b. This way. Right? A to the power 1 upon x equals b mean the same thing I can write. B equals a to the power 1 upon x like this. Correct? Same thing I wrote. This equals b mean b equals this, no? Correct, no? X equals y mean, people. What do you mean by this? X equals y mean y equals x, no? Like that. This equals b means b equals this. That's what I wrote. Now here, when you follow, you can see what is there. Here, what you have is, people, the number, the value b has been expressed as a power of b. What is this? We have index form of b. Index form of b we have. Then we can convert this to logarithmic form. How? Logarithm b to the base a equals 1 upon x. This way. Correct? No? Okay. Then what is x? X is this here, log a to the base b. Now you can put there. Therefore, log b to the base a equals 1 upon x is this, log a to the base b. This is how we do it. Correct, no? This kind of proof you should expect at your first term test. Right. Do that, people. Right. Now we'll take people one example like this. Suppose here we have 2 divided by log root t x. Asking to simplify this. 2 divided by log x, base is root t. How to simplify this now? Right, people, now this law, I explain only the right word use here. The log terms in this left hand side we have at the numerator above the line. When you take that to denominator, I told you these two numbers exchange and we can write. That is how we read from left to right. Right to left. The log term here we have at the denominator. You can write at the numerator as here, again interchanging these two numbers. Therefore, that also you have to understand. Now we can apply that here. What people? This log term is at the moment denominator. No? Bring this to numerator. Then it is 2 times. What happens? Log these two numbers exchange the places. Root t comes here. Here we get x. I think you can understand that well. Like this. Okay, no? Now the third law we learn, people, the coefficient is 2. We can put where here, no? Okay. Then you can apply that. This is now log base x root t perfect square. Taking this 2 as the power of this. People, what is root t perfect square? Root perfect square means the root will eliminate. We say like that. People, root means power half. No, we told no. Root means power half. Root means power half. For instance, suppose this simplification, root x to the power half. Now I square left and right. Then right hand side x to the power half, we have to square like this. Right. Now on the right hand side we can simplify using the index laws. the inner power half should be multiplied with the outer power 2. Then we get what? X to the power half into 2. You know, when we multiply half by 2, we get 1. Then we get x to the power 1. X to the power 1 means x. Therefore, left hand side. Root x perfect squared. Root x perfect squared is equal to x. Then we say, people, when we square here this root, when we square, we say the root will eliminate. Once we eliminate the root, what do we get? We get x, no? Right. That is why we say when we square root sign, it eliminates, disappears, right? Then here, root t squared means, people, this root sign will eliminate, only t we get. Then this answer going to be log t to the base 6 is this answer, right? 2 divided by log x base root t mean this, people. Understood? Right. That's the fourth law. Right. The fifth law is, people, change of base formula. Change of base formula. Right? Yeah. The change of base formula, people, very, very important formula in logarithm. Okay. Yeah, I'll explain that. People, now suppose you need to find something like this. Log 2, 5. That means logarithm of 5 to the base 2. This one, when you try to find, people, you know, if you are asked to take the answer of this logarithm, 17 to the base 10. To find this, you can use your usual logarithmic table you used in your oils. Thereby, you can take this answer. Take in logarithm table. But here, to find these, people, you can't use that your usual logarithmic table that is given every logarithm subject to base 10. But this time asking logarithm of 5 subject to the base 2. Subject to the base 2, the logarithmic values cannot be found by using the logarithmic table subject to the base 10. Your usual oil logarithmic table, people, subject to the base 10. So then, to take this answer, we must have a logarithmic table which is prepared subject to the base 2. Such a logarithmic table not available, people. Not available, such logarithmic table. Nowhere you can buy it. Then how to find this? To find these, people, this change of base formula will suggest us something like this. The base left-hand side is 2. People, this change of base formula, by its name, it says the base we can change to another new base. Now, I am going to change this base 2 to base 10. Like this, we can write it like log and log we write at the numerator and denominator. Now we write this log numerator and denominator subject to the base 10. Now the numerator this number and denominator this number, bring these two numbers in the left in the same order and keep here. Here and here. Here 5, here 2. Now earlier we couldn't find this because we didn't have, people, logarithmic table subject to the base 2. But that same thing we have written by using subject to base 10. Now you can find this value by using your logarithmic table. This value you can find. After getting that two answers, and dividing, you get the final answer, then you can get know this. So therefore, this way people writing this thing is called as the change of base formula. Change of base formula. That means the given base of the logarithm, we can change to what? Another new base. So therefore, change of base formula, if I explain people, here log b to the base a. Now you can write this as how this one you can write, introducing new base to the right. On the right hand side, we have a numerator and denominator. The new base, suppose we supposed to put here c. Then the numbers here and here of log are the respective numbers available at the corresponding positions. Draw them here. Then we get b here. Here we get a. This is called as what? The change of base formula. Understood? Change of base formula. Understand? All right. Okay. This is another important one, people. This also, there's a chance of getting in the term test to prove. Understand? Okay. All right. Write down the change of base formula. Right. We'll see, people, the proof. Right. Right. I am going to prove it like this. I take lit. I take, people, this one, log b to the base c, we take as x. This one I'm going to take, people, as y. Okay. This answer I'm going to take as x. This answer I'm going to take as y. Okay. Now I can convert this to index form. B equals c to the power x. Correct, no? Here, people, a equals c to the power y. Okay. Right. Now, what we do? Right. Right, people, now I'm going to subject C by this. By using this, I'm going to subject C. Right. A equals c to the power y, no? This means, people, c to the power y equals c, no? This equals this means this equals this one. I'm going to find, right, here, this c. Even how to find c? C can be found, people, taking power 1 upon y on both sides, like this. Correct, no? Earlier also we did something like that. The c we need to find. That means this y should be converted to 1. That is why we take both sides the power 1 upon y. Then you know the left hand side inner power and outer power we have to multiply, equals a to the power 1 upon y. This 2 you can cancel down. C to the power 1, it is c coming. This 2 you can cancel down. Now, c equals a to the power 1 upon y. Right. Now, the answer of that c, here we have c. For this c, people, the answer of c, a to the power 1 upon y, we substitute. Okay. Now you can write. Now, substitute in, right, this c in b equals c to the power x. Where? There we have B. Here I must write C. Power is 6. Right. Now inside this bracket I must write, here we have C, no? For this C we have the answer a to the power 1 upon y. Then I must write here a to the power 1 upon 1. Like this, within bracket. Outside of the bracket we have this. Now we can simplify this, how people inner power and outer power we have to multiply. Inner power 1 upon y, outer power is x. Then we multiply this to how x means x upon 1. No? Then the numerator we have to multiply, denominator we have to multiply. X upon y we get. Then here we get b equals a to the power 1 upon y into x means x upon y. Understood? X upon y. Right? Now, what we have is this b has been expressed as a power of a. Therefore, here we have index form of b. Index form of b we have. The index form of b, now we can convert to what? Logarithmic form. How, people? Log this b, a we bring where here, then this is equal to x upon y. This is what we get. Now substitute for x and y. What is your x? X is this. What is your y? Y is this. Substitute them there. Then we get this proof. Right? Now we get log b to the base a is therefore x log b to the base c y log a to the base c. This way we can very easily prove the result. Right? Yeah. Right. Prove this, people. Okay, no? Right. And now we're supposed to come to the end of the class here. Right?